number one, today we're going to be solving inequalities. Solving inequalities is pretty much the same as solving equations. There are some additional rules, okay? So the first thing I would like you to do is rewrite this inequality below the number line so that you actually have some room to work it. Why is this called an inequality instead of an equation? Right, there's no equal sign, there's an inequality sign. Remember, when I say inequality sign, I'm talking about either a greater than or equal to, a less than, or a less than or equal to. Okay, those are your four different inequality signs that we're going to be dealing with today. So for number one, when they say solve, that always means to isolate the variable. What is the variable here? R. Why is R not by itself currently? How is 8 attached to it? How do you undo multiplication? Right, so if we divide by 8 on this side, what's 8 divided by 8? Is there any need to write the 1 beside the R? No, it's understood to be there. When we divide by 8 on this side, we get a -3 and then just bring down the sign. So, what this means is that we have many solutions. You know, like with equations, let me just stop for a second. Let's just pretend for a second that this had said equals -24. Wouldn't you have done the same? You would have divided by 8 on both sides and ended up with R equals -3. Isn't that only one solution? Isn't -3 the only solution for that equation? Because it's the only number that when plugged in and multiplied by 8 would produce a -24. With inequalities, there are many solutions. Every single number that is greater than or equal to -3 is a solution. So like, what are some numbers that fall in that category? Greater than or equal to -3? -3. Okay? So if I plug in a -3, 8 times R, which I'm saying is -3, is greater than or equal to -24. Let's see if that produces a true statement. What is 8 times -3? -24. Is -24 greater than or equal to -24? Yes, it's equal to. So see how when I plugged in -3 it made a true statement? What's another number that's greater than or equal to -3? -2. So let's see what happens when we plug it in. What's 8 times -2? Is -16 greater than or equal to -24? Yes. Okay, what about a number that's not greater than or equal to -3? What? Okay, -4. When you plug it in, what does it give you on this side? Is -32 greater than or equal to -24? No. Even though 32 is bigger than 24 normally, since we're talking about negatives, the bigger it is, the smaller it really is, right? Because it's further away from 0. So that does not work because it did not fall in the solution set. The solutions are all numbers that are greater than or equal to -3. Now the way you show that on the number line is you go up and you circle -3. Put a circle around the notch for -3. Was -3 actually one of our solutions? Yeah, when we plugged it in, didn't it make a true statement? Since it's actually included in our solutions, you shade it in. It's a closed circle. And then weren't the rest of our solutions greater than -3? Which would be to the right of it? Think about it. Aren't these numbers greater than -3 and these numbers are not? So we draw our arrow that way, showing that this number and all numbers this way forever are the solutions. Okay, now another thing we're going to learn today is called interval notation. Everything I just said you've seen before in 7th grade, but you have never seen interval notation. Stop. Okay? Interval notation is just another way of writing the solutions. So, on this number line, what is my lowest solution? -3. What's my highest solution? Doesn't that arrow mean it goes on forever? And what is forever? Infinite. Infinity. Okay? Now, infinity, you always put parentheses when you're doing interval notation. But since we actually have a solution at -3, you put a bracket to show that your solutions start at -3 and go forever. Okay, let's try another one. K minus 3 is less than or equal to 3. Okay, so this time we need to solve for K. So what do we need to do first? Add 3 on both sides. Okay, on this side, -3 plus 3 is 0. Well, is there any need for me to write K plus 0? No, so I can just mark it out and not write anything. But on this side, 3 plus 3 is 6. So that's our solution. Every single number that's less than or equal to 6, so like 6 and below, are solutions. Look, if I plugged in a 6, let's see what happens. 6 minus 3 is 3. Is 3 less than or equal to 3? Yes. Okay, so 6 is a solution. Now let's plug in something less than 6, like 5. 5 minus 3 is 2. Is 2 less than or equal to 3? Yes. What would happen if you plugged in a number that was not less than or equal to 6? It would not make a true statement, like 7. 7 minus 3 is 4. Is 4 less than or equal to 3? No, it makes a false statement when you plug in a number that's not really part of the solution. So now to graph the solution, I go to 6 and I circle it. Is it going to be open or closed? Closed. Because wasn't 6 an actual solution? And let me tell you the easiest way. If it has an equal to bar, it's going to be closed. Okay? If it has the equal to bar, it's going to be closed. Now, all our solutions are less than that. So which way? To the left of 6. Numbers lower than 6 are our solutions. If you plugged in numbers that are higher than 6, they would make false statements, right? Okay, now let's write the interval notation to represent that. What is your lowest solution you could have? Your lowest solution. Isn't it going forever into the negatives? So do we really know what the lowest one is? No, so you write negative infinity. And the reason you write negative is because you're going left into the negatives. And you put a parenthesis. What is your highest solution that could go in there and make a true statement? 6. And 6 actually makes it true, right? So you put a bracket. Okay, why don't you take a second and try number 5 before I go. Alright, number 5. The first thing you should have done is rewrite it so that you actually have some room to solve it. Correct. We're going to subtract 10 on both sides to get it away from the v. And so v is greater than or equal to 7. That means all the solutions to this inequality have to be 7 or greater. So like 7, 8, 9, 10, 11, 12, 13, all the way to infinity. On the graph, is it open or closed circle? Closed. And then remember I said all the solutions are 7 and above, so wouldn't that be to the right? Now for the interval notation, what is your lowest number that could be plugged in and work? 7. What's your highest? Right, they go forever, so you put infinity. You always put a parenthesis on infinity. On the number, since 7 is actually one of the solutions, you put a bracket. We'll do one in just a second where the number is not included in the solution, and so you wouldn't put a bracket. Yes? No. V minus 8 is greater than or equal to negative 8. What do I do first? Right? So on this side, they cancel because it's 0, and you don't have to write v plus 0. You just write v. On this side, they become 0 also, but you do have to write it because you can't just leave a blank. Okay, so you actually have to put a 0 there. So we circled a 0. Is it open or closed? Closed, because it has an equal to bar. And all the solutions are what then 0? Greater, which would be which way? To the right. Numbers like 1, 2, 3, 4, and up are greater. And plus, it points to the right. Okay, now let's do our solutions, or our interval notation. What is the lowest solution, the lowest number you can plug in and work? 0. And you actually can plug in a 0 and it works, so you put a bracket. What is the highest you can plug in? Right. There's really no highest number. You can plug in numbers forever. Yep. You can just do that. Okay, number 9. P minus 9 is less than negative 13. Correct. We're going to add 9 on both sides. Those 9's cancel out because they're 0. And now on the right side we have a negative 4. Okay? So this time, look, there's no equal to bar. So the solutions are everything less than negative 4, but not negative 4, because there's no equal to bar. So for that reason, you do an open circle. Let me show you why negative 4 is not in the solution set. If I plug in a negative 4 right here, what's negative 4 minus 9? Negative 13. Is negative 13 less than negative 13? No, it's equal to it. So you would have needed an equal to bar to be there for negative 4 to have worked. So to show that negative 4 is not really a solution and that it doesn't make a true statement, you do an open circle. All of the solutions are everything what the negative 4? Less, which would be which way? Left. And see how it's pointing to the left? Okay, now we got to do our interval notation. What is the lowest number you can plug in and it'll work? Negative infinity. The highest number is negative 4, but pay attention, this one's different. Can you actually plug in a negative 4 and it work? No. So you put a parenthesis on that as well, showing that the solutions are everything below negative 4, but not including negative 4. You only put a bracket by the number when that number can actually be plugged in and work too. Okay, next page.
We don't have homework today, huh?
Yes.
Oh, good.
Number 11. What should I do first to this? Okay, on this side, those can combine to a what? Negative 9b. Okay, negative 3b minus 6b is negative 9b. Now what can I do to solve for b? Divide by negative 9 because they're being multiplied. So those cancel because it's just 1b, but you don't have to write the 1, and then that becomes negative 2. Okay, but let me show you something real quick. Doesn't that mean that all the solutions are less than negative 2? Give me a number that's less than negative 2. No, negative 1's greater than negative 2. Negative 3. Watch what happens when I plug in a negative 3. What's negative 3 times negative 3? What's negative 6 times negative 3? Positive 18. What's 9 plus 18? 27. Is 27 less than 18? No. So we have a problem. Even though we ended up getting b is less than negative 2, and we plugged in a number that was less than negative 2, it didn't make a true statement. That's because there's a rule that many of you probably don't remember. Whenever you divide by a negative number on inequalities, you flip the sign. Okay? Now let's try a number greater than negative 2. What's the number greater than negative 2? Negative 1, 0, 1, whatever. So we'll try negative 1. If I plug in a negative 1 right here, what's negative 3 times negative 1? What's negative 6 times negative 1? When you add those together, you get a, is 9 less than 18? See, now it works. You have to remember that anytime you divide by a negative number, you flip the sign. So now we circle negative 2. Is it open or closed? Open, because negative 2 won't actually work. Negative 2, when plugged in, would make an 18, and is 18 less than 18? No. So that's why you keep it open, and then the rest of the solutions are what the negative 2, which is to the right. Okay, now let's do our interval notation. The lowest solution is negative 2. Is it actually included in the solutions? So you put a parenthesis. The highest solution is infinity, and you always put parenthesis on infinity. Okay, why don't you try number 13? Here we go. 3 is less than what? What do those combine to be? 1m. Do I really need to write the 1? No. So isn't that pretty much the final answer? So what number do I circle? 3. Is it open or closed? Open, because there's no equal to bar. But doesn't this say that the solutions are greater than 3? Which is which way? So why is it that this time this pointed to the left and I went to the right? The very didn't come first. Did y'all hear that? With every other problem we've worked out, the variable was on the left side. So you could just look at the sign and know right or left. But with this one, the variable was on the wrong side, so you go the opposite way.
So if the variable is on the left, then we have a way to find points which way to go.
Right. Like, think about it. If I rewrote this and I put M on this side and 3 on this side, remember the M is being eaten. So don't I still need to eat the M? Well, now look, it is going to the right.
That's what I wanted to ask.
Okay, so now let's do our interval notation. What is the lowest number we can plug in and work? Well, not and work, but the lowest number is 3, but can you actually plug it in and work?
No.
No, so you put parentheses. What's the highest number? Infinity. Okay, number 15. What do we need to do first? Okay, obviously we've got like terms over here. When you combine them, what do they become? Negative 2b. Right, and then plus 1. So now to solve for b, what do I need to do next? Subtract the 1 on both sides. Those will cancel. Remember, I'm trying to get everything away from b. So first I take this 1 that's positive and subtract it over. That becomes 0 is greater than negative 2b. And now what do I do? Divide by negative 2 on both sides. Those cancel, and so isn't that 0 is greater than b? Or couldn't that be rewritten like this? Think about it. If you rewrite it so that the letter comes first, you need to make sure the sign is still eating what it was eating before. It was eating the 0, so it still needs to eat the 0. So now we circle 0. Is it open or closed? Open, and then which way do we go? Left. Everything less than 0 would work. Okay, so now let's do our interval notation. How far to the left does this graph go? Negative infinity. How far to the right does it go? 0, but you put a parenthesis because 0 is not actually included in the solutions. It would not make a true statement. Anything less than like negative 1, negative 2, negative 3, and forever to the left are the numbers that would work when plugged in. Okay, when you look at the left side of this inequality, is there anything you can do? No, you can't actually add that 21 to the negative 3b because they're not like terms. This one has a v, this one doesn't. What about the right side? Right, you can distribute. Negative 8 times v is, and negative 8 times negative 7 is. Okay, at this point, you have 4 different options. Okay, at this point, there could be 4 different ways that you could work this. You could start by adding the 3b over here, or you could decide to add the 8b over there. Or you could subtract the 21, or you could subtract the 56. What side of the problem do we like the letter to end up on? The left. So doesn't that mean we should add the 8b over to the left side? They cancel over there, and over here we now have how many v's? 5v. And then you bring down the positive 21, and you bring down the less than 56. At this point, you only have one option, and what is that one option? Correct. This 21 and 56 belong together because they're both constants. So we subtract the 21 over to it, and so now we have 5v equals, or not equals, is less than 35. And now what do we have to do on both sides? Divide by 5. And so v is less than 7. Okay, so we circle 7. Is it open or closed? Open, because there's no equal to bar. Like you couldn't actually plug in 7 and it give you a true statement. It would give you a false statement. But you could plug in all numbers what than 7? Less than 7, which are this way, 6 and down, right? Okay, so for my interval notation, what is my lowest solution going to be? How far left does it go? Negative infinity, right? And what's my highest solution? 7, but can you actually plug in 7? And it work? No, so you put a parenthesis around it as well. Okay, go ahead and try number 19. Okay, is there anything that you can do on the left side of the inequality sign? No, you can't actually add the 7a to the negative 37 because they're not like terms. But on the right side, what can you do? distributive property. Negative 3 times A is, and negative 3 times negative 1 is positive 3. Okay, now at this point, we have 4 different options, but we like our variable to be on the left side, so in that case, what should we do? Add 3A to the left side. Those cancel each other out, and now you have negative 37 plus 10A is greater than or equal to 3. Now what do I need to do? So now we have 10A is greater than or equal to 40. And now what's the last step? So A is greater than or equal to 4. So when we circle 4, is it opened or closed? Closed, because you can have a solution equal to 4. So 4 is one of the solutions, and you show that by filling it in. And then the rest of the solutions are what then for? Which is which way? To the right. Okay, for interval notation, what is your lowest solution? 4. And is it actually a solution? Yes, so you put a bracket. You can actually plug 4 in and get the true statement. What is your highest solution? Infinity, and you always put a parenthesis for infinity. Okay, your classwork, which will turn into homework, because we only have 10 minutes left, is to be working on the evens. So until I say switch out, you need to stay in your seat and work. The evens on page 12 and 13.